Okay, so this problem deals with dilution. Dilution is the process of adding solvent to a concentrated solution, a solution with a higher molarity. When we add that solvent, the molarity of the resulting dilute solution will go down. We're going to talk a little bit about the mechanics of that process. Then we're going to talk about the mathematics behind how we handle a problem like that. So in dilution, we are generally going to take some concentrated solution that has a molarity of moles per liter of a certain fixed amount. And so we have this container that has this solution that's very concentrated. And what we're going to do is we are going to take that solution, we're going to add a portion of it to a device called a volumetric flask. It's a flask designed to have a specific capacity. In this case, in this particular problem, this volume or this volumetric flask would have a volume of 400 milliliters. And we're going to take a small portion of that concentrated solution, we're going to place it into that volumetric flask, and up on the neck of this volumetric flask, there's a calibration mark. And once we've added that concentrated solution, we are now going to add solvent, which in most cases is water, but it doesn't have to be. We're going to add that solvent until the meniscus rests directly on that line. When that happens, that device contains exactly 400 milliliters, and so then we know we have taken a certain volume of this concentrated solution and we've diluted it to 400 milliliters. And so in this particular problem, it's talking about nitric acid. In particular, taking 50 milliliters of that nitric acid, and we're placing it into that volumetric flask, that 400 milliliter volumetric flask. We're adding solvent or water to it until we get to the mark, and then asking what the new concentration would be, the new molarity. We haven't talked yet about the molarity of this concentrated solution, but in this problem it tells us that it's 16 molar. Now, that's how you'd actually perform a dilution if you were in the laboratory. How do we handle this mathematically? Well, we have what's called the dilution equation, where the molarity of the concentrated solution times the volume of that concentrated solution that we're diluting will be equal to the molarity of the dilute solution times the volume of that resulting dilute solution. So basically what we have to do is figure out what numbers go where. So let's start with the concentrated solution. We know that concentrated solution has a molarity of 16 molar. And we know that the volume of that solution that we're taking and we're placing into that volumetric flask to dilute it is 50 milliliters. Some of you might look at this and say, that's a little bit crazy what you're doing, Dr. Ramsey, because we know that capital M stands for molarity, and molarity is moles per liter of solvent. Now we're using milliliters with a unit that has liters. And I'm going to tell you that you are right. We are using milliliters with this molarity unit that is moles per liter. However, because we have volume on both sides of the equal sign, those volume units will cross out. So when we use an equation like this, and we're going to see it again for using the gas laws later, is that this volume unit and the volume unit on the other side are going to cross out. Now, let's get to that volume of the dilute solution. We are preparing 400 milliliters of that solution. So we know the volume of the dilute solution after we finish is 400 milliliters. See where the volume units will cross out because it's the same on both sides? So as long as you use volume units that are the same on both sides of the dilution equation, it doesn't matter what volume you use. Now notice we have got 1, 2, 3 of the 4 variables we have numbers for. So we can call this x, and then we can just solve that using basic algebra. And so when we do this, we end up with x being equal to the molarity of that dilute solution ending up being 2 molar. Remember, we've got to use significant figures here. We've got 3 significant figures and 3 significant figures and 4. When we're doing only multiplication and division, we end up with 3. So our answer is 2 molar. That's how we handle a dilution equation mathematically, and this is what it would look like conceptually if we were in the laboratory.